Welcome back everyone. Welcome to this module. In this module we will learn about the electronic instruments. These electronic instruments, they are mainly situated based on the principles of transducer and sensor. What is a transducer and what is a sensor? Transducer is an device. It is a device which will convert one form of energy to another. For example, a loudspeaker. It will convert the electrical energy to the sound energy. Okay. Next is sensor. Sensor is a device which will detect the input or physical stimulus. For example, pressure, temperature, and it will convert that temperature or pressure signal to the electrical signal. Okay. Now, the instruments are classified into different types. First, the instrument can be classified depending upon the quantity measured. Under this category, we have voltmeter, ammeter, wattmeter, energy meter, and ohm meter. Next, we have depending on the different principles used for their working. For example, moving iron type, moving coil type, dynamometer type, and induction type. Next classification is based on the how the quantity is measured. For example, deflecting type, integrating type, and recording type. So all the indicating type analog instruments, there are three types of torque present. First one is deflecting torque, controlling torque. Second one controlling torque. Third one is a damping torque. Now, in the analog type ammeter, there is a pointer. Whenever we give some supply to the instrument, the pointer will deflect from its initial position to the full scale value. This pointer deflection is due to the deflecting torque. Now, if we are using a 0 to 20 ampere ammeter range 0 to 20 ampere range ammeter, and if I am supplying 1 ampere current, then I will observe the 20 ampere reading by the pointer. Even if you change the supply from 1 ampere to 5 ampere, still we can observe the 20 ampere reading by the pointer. But this should not happen. The pointer reading should be proportional to the input that I am applying. That means if we think that deflecting torque is the only torque present in the system, then it is not correct. There must be some other torque present in our instrument which will bring back the pointer from its full scale value to the initial position. This torque is called the controlling torque. Alright. That means if there is a scale and on that scale the pointer deflection will be observed. Due to the deflecting torque, the pointer will move from left to right, and due to the controlling torque, the pointer will move from right to left. Now at steady state, the deflecting torque Td and the controlling torque Tc are equal. The controlling torque will oppose the deflecting torque. Now if we think that at steady state this deflecting torque and the controlling torque, when they are equal, I will get the steady reading at the scale. It is wrong because the pointer won't stop at that condition. It will keep on oscillating. So it will be difficult for us to take the reading. In order to obtain the steady deflection of the pointer on the scale, we have some other torque present which is called the damping torque. So in order to operate any analog instrument, we must have these three torques present. Now this controlling torque can be generated using the spring control technique. So here what we have this spindle. This one is spindle. This is the spindle. On this spindle we have these springs attached, and at the top and the bottom of the spindle we have some jewel bearing. With this spindle we have the pointer attached, and at the end of the pointer we have this balanced weight. And if there is any deflection of the pointer, that can be observed in the scale. So here I have applied the spring which is attached to the spindle. If we stretch a spring, suppose if we are stretching a spring at an amount of x, so what will happen? The restoring force will try to bring back the spring to its initial position. So this restoring force F is directly proportional to the displacement, or we can write F equals to Kx, where K is the spring constant. This happens during the linear motion. But when I am twisting a spring, that time what will happen? The angular torque acting on the spring, it is directly proportional to the angular deflection. Okay. Now when I am giving an input supply, the pointer is getting deflected from its initial position to the toward the full scale value. But at that time, since this spring is also attached to the pointer, the spring will get twisted and it will try to bring back this pointer from its full scale value to the initial position. So this is how, using the spring control technique, we can generate the controlling torque. There is another method we can generate the controlling torque, which is called the gravity control. In this gravity control method, we have a weight, the control weight attached to this pointer. When the pointer deflects, this weight also takes the deflected position, and the gravitational force that is acting on this weight will produce the required control torque.